Okay, folks, welcome to another installment of the SHIELD webinar. And I'm going to share my screen. Welcome. So this webinar is part of SHIELD, that is NASA Drive Center. I am the director, and John Richardson is a project manager out of MIT. And as part of our series of webinars, we had several role models that came and talked to us about the trajectory. We thought this year we are going to focus on capturing the stories of Voyager in what we call the Voyager StoryCorps. And you can tell if you heard in NPR how amazing these StoryCorps are, this series, and we wanted to capture the stories related with Voyager. And we have the immense pleasure today to have Jamie Rankin and Alan Cummings telling us stories about Ed Stone and how they were mentored by him. He's one of the giants in our field. And we thought that there is no better way to start it, having Ed Stone as a mentor and their own stories. I have my own also recollections working with him. I started my trajectory in space physics under his wing. So I'm very, very grateful for Ed Stone taking a chance on a person that came from a complete different field and was amazing. So we will get to these stories later today. SHIELD is related to the bubble that the solar wind form around the sun. We think that all stars have winds, and as they move through their interstellar medium, so the mediums that surround them, they are engulfed by the winds, creating those bubbles called astrospheres. Here are some images of different astrospheres. I like to think about astrospheres like their cocoon that surround them, like their home. They walk around with a cocoon, a home around them. We created this movie for SHIELD that show one example of what we think the heliosphere, our cocoon, look like. There's still a debate of the shape and the character of it, but this is one realization that we think, and you can see the sun in the middle and the planets around it, and how the heliosphere extend beyond all the planets and the sun and protect us. So we are very interested to know the characteristics of this heliosphere for how life began on Earth and developed on Earth. So SHIELD stands for solar wind with hydrogen ion charge exchange and large scale dynamics. The vision is to, talk among the data scientists, the modelers, the theoretician, to try to create what we say a digital twin, to understand the main processes that drive our heliosphere. And this is a collaboration, a multi-institutional collaboration, not just in US, but also international. And you can check our website here down below that show all our activities. We are centered around 4 main questions that's shown here. What is the global structure of the heliosphere? How we interact with the interstellar medium? How cosmic rays come in? And how the neutrals, hydrogen that become the pickup ions, evolve and influence the solar wind. So I'm not going to go through all the details, but you have our website. You can go and check out all our activities. And a main arm of SHIELD is the outreach and increasing the diversity within science and how science is done. And this is a diagram we created to push home this notion that we want a diverse voices in space physics. So we have lots of activities between distributed RUs, these webinars, we have a summer school, we have a leadership roles in science within SHIELD, and that we created. And we also have what we call a coffee chat, where it's a safe space for graduate students. So if you're interested in participating in any of it or know more information, please contact us, and me or Nick Ross that is leading this webinar here. And you can find all the information in our website. We also had in the past the testimonials that we will bring it up again, that you can go and check out some of the recordings in our website. I love the testimonials is a mosaic of stories of different people telling their own trajectories. And if you want to participate and record your own story, please let us know. It doesn't have to be, you don't have to be part of SHIELD to do that. So the email is shieldoutreach@bu.edu, or you can email myself or Sanlin Buxner, that is a director of Border Impact, or Nick Ross, that is a deputy director. We will give continuation to the Voyager StoryCorps in February. Having a conversation between Tom Cremigis and Kosta Dialinas, that is again, Tom is one of the luminaries, giants in the field, and Costas was mentored under Tom. So please register and attend that at StoryCorps as well. And last but not least, we have the SHIELD Summer School in June. So we have applications due by February 15. So I'm going to pass it to Alan to share his own. I'm just going to show one quick image. This is me and Ed, our in Bern in EC. I ran a team many years ago, and was amazing to have these discussions with Ed throughout the years. Even after I stopped collaborating directly with Ed, we will meet in conferences, including this one, and he always took the time to just, sit in coffee shop, look over my shoulder in my laptop, and try to understand all the wiggles in my computer simulation and debate with me. So I'm really in debt to Ed. And here is just a quick image of one of the Voyager SSGs that were so rich under the leadership of Ed. So I'm going to stop sharing, and Alan, take it away.
Okay, so just so you know, Jamie and I agreed that I would go first. And then share a few slides, and then she's going to share a few slides, and then we can open up the conversation. Just so you know, I arrived at Caltech in 1967 as a graduate student, and Ed was already here. I think he came in 1964, and he was not my thesis advisor. My thesis advisor was Robbie Vogt. And so Ed and I, although we interacted during that period, and I mainly became very closely involved with Ed right after my thesis in 1973. And I started working on Voyager that year on November the 12th, according to my notebooks. And he became the project scientist. He had already become the project scientist, Voyager project scientist, in 1972. So he was 50 years the Voyager project scientist, and he was also helping run the Space Radiation Lab, which I was now a member of, which I became a member of immediately when I got to Caltech. And so he and Robbie were running the lab. And then, Ed went on to do a lot of other things in addition to being the Voyager project scientist and working on our instrument, the CRS instrument. But what I was at his 80th birthday party celebration at JPL a few years back, and I want to share, these are adapted slides from what I presented there, and it's fairly short, but someone asked me, what stands out, what brings to mind, what to your mind when you think about Ed? So I'll show you this little presentation here. Let me go full scale. Oops, how do you get rid of this thing up there? Okay, it went away, sort of. Oh, so I refer to the 3 S's of Ed Stone. And The first one was, and by the way, Ed was present in the audience. So it didn't offend him. All of these slides did not offend him, although you might think they would. Ed was short. He was also slight. That's another S. And he was thin. And but to emphasize or to convey the shortness, I have this slide. Well, first of all, this is a picture of Ed. I needed a full-length picture of Ed, and I found one. He was giving an award to someone. I cut the person out. But anyway, his favorite spacecraft, of course, was Voyager. And to show how short he was, I put him across the antenna on the spacecraft. And it turns out it takes more than two of them to fit across the spacecraft antenna. So you may have heard this antenna is 12 of something, but is it 12 feet or 12 meters? Well, it's 12 feet. And that's how you remember it, is 2 stones and a pebble. Okay, the other thing, what is that? That's a blank slide. Okay, Ed was speedy. And I don't know how this got to be so well known basically all over the world, but he walked really fast. In fact, there was a time when the Olympics were coming up in Los Angeles where I recommended to him that he enter the speed walking event, which he did not do, but I'm sure he would have won. Everyone knew he was a fast walker, and he took steps 2 at a time. My direct experience along those lines was one of the early trips I made with him to Goddard Space Flight Center. We were going to see if my thesis experiment, which is a balloon-borne electron-positron spectrometer, could be put on a spacecraft instead of riding up on a balloon. So we had a discussion with engineers there. We worked closely with Goddard on almost all our missions, and also on Voyager. So we went to the airport. He drove, and I rode in the car, and it was like a 2 or 3 day meeting, but I took like 2 suitcases and all sorts. And of course, Ed always packed very light. But we parked in lot C at LAX, and this was a lot that's a budget lot, so it's pretty far away from the actual terminal. And the idea is you wait around for a bus to come pick you up, and you take the bus to the terminal. But Ed got out of the car and looked around. He didn't see the bus. So he said, "We can walk it." And off he went. And I was just dragging behind, and soon I lost complete sight of him. He went got to the gate long before I did. Fortunately, I did catch up with him. But so at the 80th birthday party, I calculated how much time he had saved in his life by walking so fast. And this is the equation. Oh, good. I got these bullets. So I wrote an equation for it, and it involves the following parameters, some of which you may find a little surprising, but they all come into use. So the one is the time to walk 20 steps. It's 6 seconds for him. It's normal human being is 10. The length of a step. I said he was short, so it's only 2 feet 2 inches for Ed. The number of feet in a mile, 5,280. The distance in miles from the sun to Voyager 1 on January 25th, 2016. The speed of light, of course, that would come in. And the years Ed Stone has been walking fast. This would be his 80th, and I gave him after 2 years old. The number of seconds in a year, number of steps per day, days in a year. So TS is not the termination shock. It's the time saved by Ed Stone over a normal human being. And that ended up being this equation, which has all the parameters in it, and it comes out to be 1.8 years. So at that point, I declared that celebration was canceled. We should all go home. Okay, another blank slide. Oh, I see. So the third S is that Ed was smart. And that was evident to me right away when I met him. And he moved up the ladder at Caltech very quickly from research fellow to associate professor, and became the chair of the Department of Physics, Math, and Astronomy, became the director of JPL, worked hard on getting the Keck telescopes built, and he was working on the TMT towards the end. So I have one slide that doesn't necessarily how smart he was, but he accumulated a lot of paper. And this was his office in the other building before we moved over to the current building. In 2009, we moved here. So this was before that. I don't know when. Stu Hartman sent me this slide. Oh, you know what? I just remembered something I wanted to say on the previous how fast he was. And it was a joke that Dan Baker came up with years ago. And that was that nobody knew what Ed looked like, because when he was coming towards you, he was blue shifted, and he was going away from me, he was red shifted. So I need to get that in there. But anyway, you could walk into Ed's office and ask for something, and he would get up and go over to a stack, pull it out and show it to you. He knew where everything was. The meetings were a little weird in his office with all that stuff on the desk. But I could think of two other letters that come to mind about Ed. I've already mentioned his leadership roles. He was principal investigator of many missions and instruments, and of course, all his leadership at Caltech, in the departments, the chair of the department, was vice provost for astronomical facilities. So that would be L for leader, but M also for multitasker. He was the best multitasker person I ever met. And I told this story before, but when I was working on Voyager problem, and he was in my office during the time he was the JPL director. So somewhere between 91 and 2001, I was up at the board, at the chalkboard, and I was writing something, and the secretary came in and said, "Ed, you have to go to Washington, D.C. right away. Dan Golden wants to meet with you and the other center directors, I guess." So we walked out of the office, and 3 or 4 days later, he comes back in. We don't have any chit chat. He just motioned me back up to the board, and we resume in mid-sentence where we had left off. And so he never missed a beat on stuff like that. He could remember everything, and it was just so smart. So, there's another thing. He got to be very popular after the last encounter, well, during the encounters, really, because he was leading the daily press conferences at each of the encounters with Jupiter, Saturn, Uranus, and Neptune. And so that was in about 1989 was the last one. So after that, he began to be featured in numerous articles, People magazine. There was one, New York Times magazine. But I like this one from Washington Post, January 2nd, 1990. He was, if you look at this top romancers down at the bottom, the Corbel Champagne people named the top 10 romantic people for 1989. And there is Ed Stone. So, along the likes of Tom Cruise. Okay, and I found this, what I call the photo shoot for that top romantic people. This was a caricature with the little Voyager spacecraft up near his top of his head. Okay, so that was the end. I'll stop sharing. And I'll let Jamie have a go at it.
And start thinking. I have questions for Alan already. But start thinking about questions after Jamie finish. You can put it in the chat, but I have my own questions about you and Ed.
Okay.
Okay. Thanks, Alan, for sharing that. That's great. Let's see. Okay, people will see this hopefully. Yay. Okay. All right, let's see if I. Nope. Switch. There we go. So hopefully people can see their correct full screen view. All right. So my timing when I met Ed was as a graduate student at Caltech. Actually, even before being a graduate student at Caltech, you kind of go through an interview process where there's like a visiting day and like spring before arrival, and so I met with all of these professors, and I came from the University of Utah. I didn't have a lot of examples of people in my family that had really gotten a degree beyond like a bachelor's degree, if that. And so I didn't really know what it was like to go to graduate school. So but I had some fantastic mentors at my undergraduate institution that had big dreams and that basically encouraged me to dream big as well. And so got accepted to Caltech, and I was in the spring of 2012 just interviewing all sorts of professors, meeting with them, and I just really enjoyed talking with Ed. He seemed very down to earth and approachable, great smile, very peaceful personality compared to a lot of other professors I had emailed and interviewed and discussed things with. And so a lot of people ask me, what was it like? They're like, how did I actually get to working with Ed Stone? And I just asked him, I said, so would you be interested in taking on a student at this time? And he just said yes, and that was it. And that was yes. And so it was really straightforward. seemed really easy to me at first, but also he told me, we had this discussion after I graduated a few years ago. We had this discussion on how it was just perfect timing. All of it was related to perfect timing. And Ed Stone has a whole career of being involved with things at just perfect timing. And it was interesting timing for myself when I first arrived at Caltech, because that was 6 days after Voyager 1 crossed the heliopause. And that's when I started graduate school. And my first day on the job was attending a Voyager SSG meeting. And I was wearing this t-shirt here, and there's a picture of it. And I was wearing like flip-flops and sandals because I was told this is California, you know, they're casual. And so I come into this meeting and there's all these people with like suits and ties arguing about like all this data on the screen. And I barely knew what Voyager was at that time and what it all meant. But I remember trying to sneak into the back. I thought, oh no, this is a different sort of meeting than I'm dressed for. And I tried to sneak in the back, and then Ed Stone was running the meeting, and he kind of waved to me. He's like, oh, Jamie, good to see you. And it was like, I was very embarrassed, but I was also surprised that I was so thankful too that he acknowledged me. And they were arguing about senior review and how to represent more young people and stuff. And it's just really funny because that was the context when I just first walked in. And it was pretty incredible actually to see that whole journey of the Voyagers and like crossing the heliopause and the whole history of all that data in the interstellar space. But I also had a fun, interesting time. I basically, shortly after that, I decided I've got to see the JPL, because if Ed directed JPL, I mean, I have no excuse to not go tour the campus and all that. And so I took this campus tour a couple months later, basically. And so that around campus was the 35-year anniversary celebration of JPL. And I was amazed. I was amazed moving to California at just everything I had read in textbooks was right in front of me. Seeing like space operations facility, all these things were just incredible. And I remember I was in this tour with all these people, and we were kind of like waiting in line for going into the space flight operations facility. There's all these people from all sorts of backgrounds all around the world. And I remember the tour guide was trying to get everybody to come, and they were all paused because they were looking at this deer and they were convinced that, wow, JPL's robotics are incredible. And the deer basically was just so still that it kind of looked like, maybe, I guess it looked like a robot. I don't know, to the whole entire crowd except myself. They basically, the deer turned its head and they're like, wow, those robotics are so realistic. And then it just got up and ran away. And then everybody said, oh, and then they moved on to the next part of the tour. But they had thought that was a part of the tour, which is funny. And later that day, that evening, was the, I guess it's like the von Karman presentation on crossing the heliopause. So that was pretty incredible to, and Ed included me on all these things. He made sure that I could participate and see as all these events were unfolding, even though I could barely understand it at first. And there's Susie Dodd, kind of introducing Ed as he's about to go up and talk about all the evidence of the Voyagers crossing the heliopause. And there's Ed in action, and kind of one of his very favorite plots to show all about this story was the cosmic rays, and how the kind of low energy heliospheric ions kind of went down and the cosmic rays went up. And I would see Ed, I think pretty much daily, he would print out the plots as the next data point would come in, and he would repost that on the bulletin board in his office until all the data got filled out. I thought it was pretty incredible. I could tell that he just so valued getting the data in, and just he wanted to update every single day with the new data points that had arrived. He's always keeping that up to date, which is pretty incredible. And there's a picture of us in front of the Voyager there in the von Karman auditorium. And I guess I would say it's pretty incredible to have him as a advisor. He's my PhD advisor at Caltech. We were 52 years and 1 day apart in age. His birthday was the 23rd of January, and mine's the 24th. And so it was fun to always say happy birthday to him and all this. But he was an incredible mentor. And one of the things that really kind of shaped my whole entire career was his philosophy about, in terms of his mentorship, of making sure that I not only just looked at the data and looked at kind of what was on the Voyagers and what the data was returning, but also that I got a firsthand experience of my own to kind of contribute to science as an experimentalist. And so it's like very important to him in my thesis and my graduate career to get a balance of the data analysis and the science, as well as like the experimental work in the lab. But it was really, really important because he had me lead with the science. And that I see now totally makes sense in how it kind of made a huge difference. But while I was there, a large part of what I did in addition to Voyager was also helping out, taking the measurements with Parker Solar Probe. And it was pretty incredible. It was incredible to work on the epi-high sensor of Parker Solar Probe, because there's just so many parallels with like CRS on Voyager, and it's incredible to get like that well-rounded experience as an experimentalist, and also being able to do good science with it. And so it's pretty incredible. Around the time basically Parker Solar Probe launched the day after I submitted my thesis, and I actually went to go see the launch. It was pretty incredible. I took a crazy 1 day trip that if I hadn't been so short on sleep because of trying to wrap up my thesis, might not have tried to do, but I did it. It paid off. It's pretty incredible. But I had just an incredible time just at Caltech, being mentored by Ed and learning all of his experience, learning all of his wisdom in general, working on the incredible science, but also setting up missions that and instrumentation, building instrumentation, things will leave a long lasting impact. And so, so that's pretty incredible. And I'm really thankful to Ed for successfully passing on that knowledge to the next generation. And I guess a few generations removed for multiple generations. But in this case, here's an example. So little did I know, like while I was just working on these small steps and detectors and stuff, little did I know, like that would pave the way for my next step to myself be leading an instrument, which is this is my instrument that I'm leading on IMAP. There's me in a clean room suit and stuff, and then leading my whole teams of people and students and teaching and mentoring and passing that on. So anyway, I'm so grateful to Ed and really the whole group at Caltech for just the incredible time that it was to be there, and to get a really well balanced perspective on the science from the concepts of what drives a NASA mission, why to explore these parts in space, to the actual, step-by-step implementation of like, measuring all the things, make sure they work right, working with the data, make sure that looks good. It was a very holistic experience, and I am so grateful for that.
Fantastic, Jamie. I just found the picture, and so I will tell a really quick story, and then we will open for questions. When I got this is my first experience with Ed. This is of the this is I think was the 25. Yeah, it was just when I started as a postdoc. Alan might remember when I came from my first Voyager SSG. It was my second postdoc, and Paulette Lewer was my boss at JPL. And then she said, I cannot go for this. I assigned you to do it. And was me, Ed, and Andrienne and Susie. And we were talking about and before that was with Frank McDonald talking about did we cross a termination shock or not? And so that was a lot of fun. But the little story I just want to add about Ed, you know what I learned working with him in our first paper we did in 2006. I started working with him in 2004, and it took 2 years for us to publish together the first paper. And it was really, and I want to actually ask you guys, Alan and Jamie, if you had similar experience. I am a much more intuitive scientist, much more, I like orders of magnitude, hand wavy arguments, and Ed will be looking really kind of serious and trying to formulate how crazy this idea. And I am so appreciative that he never really said, no, it's crazy. He will come. And I think I told this story when he, in his birthday, when he was 70, it's almost like he actually did for one of our meetings, bought his wooden ruler and tried to measure every wiggle in my computer simulation. And I was trying to tell Ed, those simulations have so much uncertainty that you can't do that. And he's really trying to quantify like it would be a lab experiment. And, we're trying to figure out, is the interstellar magnetic field distort the heliosphere by how many AUs? And he's really trying to say, it's half of a U. And I said that it's orders of magnitude that we don't know. And it was really, really fun. I felt like working with Ed, we were translating between two different languages, but he never said no. It was like the ideas were so important for him that we kind of, okay, the ideas might be okay, but let's figure out, can we do it quantitative or not? But took us 2 years, this translation, until Ed said, okay, paper is ready. So that was a fantastic experience. Alan, I have my question for you. How was to start working with Ed? Because Jamie told her piece. How was to, when you just first met Ed?
Okay, so you may have heard this story, but the first part of my interaction with Ed came right towards the end of my thesis. I was still messing around on tangents. And, every time you make some progress on something, it opens up another little problem that you sort of pursue that, go off in all these tentacles. And he stopped by my office one evening and said, "What are you doing?" And I told him what I was doing. He says, "No, you need to finish up." This was 6 years in, almost. And so he inspired me to write up what I had and move on and get my PhD. So this was maybe 6 months or 9 months before I did the writing. So I originally worked, 5, 6 years on this balloon experiment called E plus minus. This was the same thing that Carl Anderson got his Nobel Prize with at Caltech, except it was adapted to a balloon experiment. So we had spark chambers, we had a magnet, and we had a gas shrink-off counter on top. Well, I probably would have kept working on that for years with Robbie Vode, I suppose, had it not had this little accident in Churchill, Canada. It was the first year I was kind of in charge of everything. Robbie used to go up every year and be the professor in charge of. We would have more than one balloon experiment. There was P off E. There was other ones. The E experiment. But that year it had gotten reduced to just E plus minus in 1973, the summer of 73. And the balloon got launched. It was the world's biggest balloon at the time, 50 million cubic feet. We wanted to get to the top of the atmosphere. And it went on its course, which was a slow moving westward trajectory. And after 24 hours, typically that's what you got before it got to the mountains, and it was hard to recover. So you were tied to a parachute as well. And there were two things that should cut the parachute loose. One was a command, and the command failed. And then the other was a backup timer system, and that failed. So it kept going around the world. Eventually we packed up and came home, and we would get reports from pilots around the world. Said they'd seen it, and it looked like it went around the world 1.5 times, and then it got low enough in altitude that the Russians brought it down. And I was actually, Robbie was supposed to go over and get the remains, because the Russians said, "Okay, we have it. You can come point out what you want, and we'll send it back." And this was in the Cold War, 1973. So I went over there because my Robbie got sick after the Denver 1973 ICRC. He became very ill. And so I was elected to go. And so I went over there, and I had quite the experience, unbelievable experience, several days. It was over a holiday in September. And I did point out stuff, but there were things that were missing. Also, all the little microdot connectors on all the boards were gone. And they were made in Pasadena or South Pasadena. They were gold and shiny, so I guess they liked the look of them. And then the cameras for our barograph were missing, 2 of them. We had 2 barographs. We had backup. We were redundancy oriented, and both cameras were missing. And so I pointed that out, and they said, "Oh yeah, some kid came off the street and stole your cameras, but we have the film." And they handed the film to us, to me. So I had these 2 rolls of film in my possession, and my headquarters was at the embassy. So my person that was driving me around took me back to the embassy. Fortunately, I didn't get stopped, because when I got to the embassy and read out the films, there was secret stuff in the very inside had been spliced on. And the guy at the embassy said, "Oh yeah, you could have been it. If they caught you with that, you're going to be a hostage. You're going to be in jail, and you're going to be negotiating for your freedom." So at the end of all of that, and I got back, and Robbie and Ed said, "We're not doing that experiment again. It is smashed beyond repair." And it was. So they said, "Okay, we have another project. You could work on this thing called MGS 77. and that became Voyager. So I started really early on in November of 1973, and then I began to work really closely with Ed. All the rest of the 50 something years I've known him. I mean, he was in my office a lot, and we worked on first just building the instrument, and he figured out a good way to do a thickness map, not exactly a detail map, but what was required for the thickness of the thin detectors, so we could have good element resolution. And I was in charge of carrying out all these kind of calibrations and stuff. But so he was doing all these other things he was doing, in addition, designing how to calibrate our detectors and build our instrument, which we did. And then, of course, we went directly into data analysis mode, and he and I worked really closely on everything Voyager related. At the same time, there was a lot of other missions coming up. When he was the director of JPL, he was also the ace PI for the whole mission. And I remember a time when we were having trouble at JPL getting our instrument into thermal vacuum because some other instrument at JPL wanted to be there and thought they had priority. And so during this battle, Ed wanders down. He didn't say anything. He didn't tell the other team that my instrument has priority over your instrument, but nothing was said. But the guy recognized who he was, because it's very it's almost kind of military like over JPL there. You don't go from a low level and talk to the director directly. You talk to intermediary people, but there the director was, and they said, "Oh, that's Ed's instrument." Well, pretty soon we were in the thermal vacuum system first. So just showing up made a difference. We were entitled to it anyway. It wasn't really wrong. I thought we were getting screwed. But no, Ed was such a close associate for 50 plus years. It was really hard when he retired and became sort of disabled, and very sad. He was just a terrific scientist and great mentor, because didn't have him for my thesis advisor, but every other aspect of mentoring he did for me.
The other piece that maybe Jamie can touch as well is a good listener. I learned my interaction with him that, and I saw it in the Voyager SSGs, and we have other people in the audience that can jump in also with recollections, is how an amazing listener he was. His little handwriting, but just really whoever will give a talk, whatever idea it was, it's just, even if it's not, if it in the paradigm you're thinking, he's listening to see if it makes sense. And the other memory I have with him, sitting next to him in an airplane, he's staring at his slides that he was going to give a summary from Voyager forever. And he was studying how to best tell a story. And just that concise form that, you learn by just observing him, that it take a real talent, which figure you're going to show that really capture the story. I was extremely impressed. Anybody in the audience that want to jump with recollections on Ed or questions? I cannot see. Derek, Audrey, Bill, please unmute one of you guys. Yes. Derek, you want to go first, and then Beth? Derek, I think you have to unmute yourself.
Did you mean to request that I unmute? I don't know if the Derek got the request or not.
So Bill Kurth is saying maybe they can't unmute themselves. You have to unmute them or somebody.
Yeah,
So-
I think the guests
I'm-
get Or
So I'm working on that, and things keep moving around. So
Okay, so Audrey, you can start your question, and then while Nick figure out with Derek. Audrey?
yeah,
Yes.
sure. I
Great.
heard him at that tail end, so I wasn't sure what was going
It's
on.
okay. It's okay. It's okay.
No worries. Thank you all so much for being here. It's really amazing to hear that. I'm just finished my undergrad degree at UChicago and I'm starting my PhD here. So it's been amazing to be able to learn more about Ed since I know that he was here back in the day as well. Jamie, I really resonated with, as I was like doing my grad search, something that you mentioned about it being incredibly important to have that balance between data that is taken and that you analyze and things that you do in the lab. I was just wondering if there were ever any challenges that you encountered with that and finding that balance throughout the course of your PhD, and if there were other pieces of advice that Ed had for you as you dealt with that.
Oh,
That's
that's
a
a good
great
question.
question. Yeah.
So Ed actually turned out a really big fan of like having healthy work-life balance. I found it very interesting to try to balance like, you know, working in the lab and actually like writing the thesis and all that. And I guess I just followed like his sort of example. He was a very hard worker. And I basically just took a basically note from him of how well like he could set like very clear goals and stuff, and he was willing to like meet and discuss things so I wouldn't get stuck. So that was like a huge important part. And in the meantime, in addition to you know, like working hard on those things, he definitely found it really important for me to you know, pay the attention I need to my classwork, but also he supported like some of my extracurricular activities. I was actually at first nervous, like should I only be in the lab all the time? Should I only be writing my thesis all the time? And it turned out there was while I was at Caltech, some good friends of mine wrote the first ever Star Trek musical, and his daughter was a part of the show. And so anyway, I was like, I was really nervous to tell Ed that I even participated in it because I was the lead of the music and it took a lot of extra free time. But then I remember running into him during a show and he was like just thrilled that I was a part of it. So that was really cool. And there's times where we both played the French horn, and I won a concerto contest at Caltech, gave a concerto, and it was so cool because he was right there in the audience. That was incredible to me. So I guess I learned how to kind of like manage the time well, but also know exactly when to stop working because it just simply wasn't productive and go do something else like my music or something. And that was hugely beneficial. And I guess one of the biggest things that Ed would have me do is if there was a thing that I was stuck on, not to like just like spend forever just spinning my wheels in front of it, but like to set it aside, move on to another thing, and then come back to it. So that was like very, very helpful and effective. And oftentimes I did find like after I performed in a concert, oh yeah, okay, here's the answer to that like question or something. And then I guess another thing that that I learned in working with Ed on all this stuff was the importance of just taking a lot of notes. He did an incredible job taking notes, and sometimes I'd be asking people like for things, and they would talk all about it, and I found it very efficient to like take those notes and then just take those actions, and I think those sorts of things ended up saving me a whole lot of time and helped me in my just overall organization planning of things and how to balance all that.
Fabulous, fabulous, fabulous. Derek, thank you, Audrey.
Yes, ma'am.
Derek, you want to jump and ask your question?
Yes, ma'am. Can you hear me okay?
Yes, perfect.
Oh, perfect. Thank you very much. I'm out in the wild, folks. I apologize if I'm coming in a bit choppy. I'd like to ask a question from a boots on the ground perspective. As a member of the general public, there are some reports that come out about a follow-up mission, an interstellar mission that would follow up the Voyager spacecraft. So I cannot think of a better group of individuals that could be a gateway or vet that kind of communication. Number one, if it's actually true. And number two, if there is any substance to that information, what do you guys think Dr. Stone would think about that? And I really appreciate your time. Thank you.
Well, I can say that Ed was totally in favor of the interstellar probe. So that is a mission that's been in the concept stage for many, many years, probably 20.
Yeah.
But, and whether it comes to fruition or not, I don't know. It has to compete with other missions, but
A couple of years ago, there was a conference that I participated with Ed in Caltech, trying to figure out the best way to do interstellar probe. Now,
I
in
was
the
part of
last,
that one too.
yeah. And I forgot the name, maybe Jamie will remember. But
Tech Institute for Space Studies.
yes, exactly. And they have a different, proposal for that mission now. And we just had a decadal. It's a study that give recommendation to NASA, and there was a lot of science in it that in favor of interstellar probe, but there is a lot of moving parts to make it happen. It's an expensive mission, so we are
No
hopeful
question.
that
No
there will
question.
be, yes, but he was very excited to have a follow-up. Yeah.
So again, as a member of the general public, the message that reverberates very strongly is that the Voyager is a mission of a lifetime. So you have, even with the powering down of instrumentation, there could be information that's flowing back through deep space that our youth and treasure of today will be able to work on for the next 30 years, which is great. But if there is a follow-up, as you say, I don't think it's going to be our call. I think the person that makes that call is probably in university right now. So that's exciting. But yeah, thank you very much for everything you guys do. It's so important.
Thank you, Derek. Bill, I see that you're unmuted. Yet,
Well, and just a response to Derek, write your congressperson. Tell him how important interstellar probe is.
I love you Americans. I'm Canadian, by the way. Sorry, better get that straight.
okay.
That's okay. Tell Colbert.
Yeah,
yeah.
I hear you. I don't want to get political, but yeah.
Well, I just put a comment in here. Jamie showed a picture of she alongside of Ed Stone, and I noticed that Jamie was shorter than Ed. So, Jamie, you must be very short. I've met you a number of times,
Yeah,
but I've never
5'8".
noticed that. I've never noticed that before.
I mean, Ned Stone could have been that short in that sense.
Well,
Well,
time is,
I will make a comment that I've worked on Voyager not quite as long as Alan. I started working in 1974 as a graduate student at the University of Iowa. And I didn't really run into Ed until we kind of got into the operations mission phase. But I was always impressed with his attention to detail and the need to make sure people got it right. First couple of meetings that we had where we were talking about what should be presented at a press conference, it became very clear that if you came to the meeting without having all your ducks in a row, you weren't going to get very far. And once you got to the point of putting together your story and doing your graphics, I think Jamie might have made a comment about this. You really have to have the details correct. I remember somebody had done a graphic to show the motion of an electron around a magnetic field, and the sense of rotation was wrong. He said, "Fix it." But he knew how to run a meeting better than anybody I've ever run into, and I tried to take lessons from him. And I've never succeeded at being as good as he was at understanding when you've reached an impasse in a discussion to the point where you say, go off and study this and come back to our next meeting and report what you find out. And he would keep the meetings going and on schedule and always accomplish what he planned on accomplishing.
Yeah, you know, during those planetary encounters, what was really impressive is that he understood everybody's science to the point where he could make good decisions about what actually got done at the encounters, and that everyone sort of agreed with. It was really nice.
Noor, I see Noor have, and I see Fran and Joseph have comments. So let's go really quick. Time is running out, but let's take a couple of minutes more because I would like to hear from Noor, Fran, and Joseph. Yeah, Noor.
So very very quick. So my knowledge of Ed is pretty limited because of what he does and what I do, but also probably the timing as well. But I talked to somebody else who is also great. I talked to Tom Crimages so much, and whenever he mentioned Ed, the level of respect he has for him is way above probably anybody else. There is really an admiration for Ed. I actually see it in Tom when he speaks. But my question, both to Alan and Jamie, so Ed grew up in a period of time characterized by the alpha male culture, the big, huge character. And that does not mean that Ed is not a big character. He is a big character too, but he's so different in terms of his leadership. How did he succeed in that culture?
Such a good question, Noor.
Oh, I can answer this unless Alan wants to.
Well, I don't think I totally understood the question, but the thing that comes to my mind is that usually you think of, CEOs and everything, really successful, wealthy people as often being very tall and big, but he was not. He was thin and wispy, and yet he was effective. They wanted him so bad to be director of JPL, and he was really torn because he was still running our group, and he was worried about what would happen to our group. And he was promised something they didn't deliver on. He was promised that they would hire a new professor to replace him and run our group, but that didn't happen. So he just kept doing it. For all those 10 years, he was coming down here and signing travel orders in the middle of the night and stuff like that. I mean, he did both, plus other things he was doing as well. In the 80s, he was working on the Keck telescopes. It's just astounding.
So I would say an answer to that is Ed's leadership style is really refreshing because he had so much respect for everybody, even students, that like working for him, people worked for him because they loved working for him and wanted to do well rather than out of fear, out of kind of like obligation or anything. It's more like people just wanted to do well around Ed, and he just kind of, brought out the best in people, I think. So it's a different style, but it was extremely effective leadership style, and he wasn't dominating. He would hear everybody. He would listen around the room to everybody's opinions and stuff, and then I think because he had a really balanced perspective, it seemed like he was able to make decisions that people would agree with because Ed made him, and I'm sure other PIs on the Voyager team could talk more about that. But I just observed that, the people loved working for Ed, and there are other types of leadership where you get the job done because you have to get the job done and you fear for your job. And, it's a very different style. And with Ed, it just kind of like, I felt myself as a graduate student, I just wanted to do my very, very best. And so that was great.
Yeah, I completely
He's been
agree.
over backwards to be fair too. That was one thing. He didn't promote CRS above other things. He was really just look for the science, the best science. What's the best science that could come out of this particular set of observations that are about to happen in an encounter or something like that. And
I think it's also it's a uttermost respect for the science. that I agree with Jamie. It's just you try to do your best near a person like that. So it was like, yeah. We are running out of time. Joseph, you want to add one last comment? And I think I see Fran said that Alan already made her point, so you can read in the chat. Joseph, you have a comment or question? Joseph, if you want, you have to unmute.
I just remember that Ed Stone was week of man of the week in the ABC News in I think during the Saturnus time, and that they made a special point that he walks very fast, so that
Okay.
might be one of the reasons everybody knows it. And my other memory is that in Adelaide we had a cosmic ray conference, and Ed in '90, and Ed gave a public lectures. I was taken aback that was such a long line for getting in. So it was really, really amazing. So thank you.
Thank you, Jamie. Thank you, Alan, for these memories. We gotta wrap it up, and join us in February to hear more stories from Tom, from Voyager, Tom Kremidis, and Kostas Dialinas, as we kick off this Voyager StoryCorps. So there will be more throughout the year of stories from the Voyager era. Thank you.